Okay, for example 2D, let's solve the equation log base 9 of x plus log base 9 of x minus 2 is equal to 1/2. So in regards to the one-to-one property, we wouldn't use that because we have two logarithms on one side of the equation and none on the other side. So we really need to use one-to-one when we have a log on one side and a log on another side as well. So for step number 2 of the process, because we have two logarithms on the left-hand side, we're going to condense it down to a single logarithm. And we can do that because we have the same base. We have a base 9 here in each one of these. Now remember that addition acts like multiplication. So we can rewrite this left-hand side as log base 9 of x times x minus 2 is equal to 1/2. And we can distribute the x into the x minus 2, and this gives us log base 9 of x squared minus 2x is equal to 1/2. Okay, so now that we have this, we have a single logarithm with a single argument, and we have the answer on the other side, which means we can write this in badass exponential form. So we have a base of 9, we have an answer of x squared minus 2x, and we have an exponent of 1/2. I'm just going to move that 1/2 a little bit closer. Now remember that raising something to the power of 1/2 is the same thing as taking the square root of it. So we have the square root of 9 is equal to x squared minus 2x, and the square root of 9 is the same thing as saying 3. So this is the equation we're dealing with. Hopefully you can see that this is quadratic. We have a second degree equation over here. So knowing it's quadratic means we want to get 0 on one side and everything else on the other side. So we're going to subtract 3 from both sides of the equation to get it in that standard form. This is what we have now. We have 0 is equal to x squared minus 2x minus 3. And again, because it's quadratic, that means we're going to have two solutions. And the solutions here are found fairly easily because this is factorable. Two numbers that multiply out to -3 and that sum to -2 are going to be -3 and +1. And setting each one of these linear factors equal to 0 gives us these two solutions. We have a solution at 3, and we have a solution at -1. Now the last thing, it's -1. The last thing we always have to do when we are solving logarithmic equations is we have to make sure that our argument's always positive. So when we substitute both of these solutions into the original equation, we have to make sure that doesn't give us a negative argument and therefore gives us something that's impossible for our domain. So let's check 3 first. Let's go back to the original equation, which is this over here. And if I substitute in 3 for x, that would give me log base 9 of 3 plus log base 9 of 3 minus 2, which is 1. So that's fine. We're not getting any negative arguments here. We have a positive argument of 3 and a positive argument of 1. So let's go and check now and see what happens if we substitute in -1. Well, if we do that, we have log base 9 of -1. Well, so there's a problem here because this argument's negative. And if we substitute it into the second bit, -1 minus 2 is -3. So we have a problem at both points. Even if we have a problem at any one of the arguments, that means that it removes this solution from our consideration because it gives us a negative value and we know that our domains are only positive. So therefore, our equation to the solution is just x equals 3. And again, we get rid of 1 because, we get rid of -1 because that gives us a negative argument, which doesn't match up with our domain.